In this lesson, this is a continuation of yesterday's lesson. We're going to be graphing a little bit more complex sine and cosine functions, and then we're also going to learn how to graph their reciprocals, which is super interesting in my opinion. So the same thing is going to happen, but now we're going to be working with these two equations right here. So just as we had before, this is going to represent our horizontal or phase shift. So this in trigonometry is called a phase shift. It's the same thing as a horizontal shift. And then this right here is our vertical shift, just like before. So what we're going to do now is focus on repeating amplitude. We know what that is. We know how to find the period of sine and cosine. And then we know that D is going to shift the graph up or down. And then we know that if we want to find the phase shift, we have to set whatever's in with the x equal to 0, nothing new. And then we also know that the negative in front reflects it across the x-axis. Okay, so I do want to point out real quick that if it's going to be part of the phase shift, it needs to be in parentheses. So this 4x plus pi belonged to the phase shift, but that plus 2 right down there does not belong to a phase shift because it's not grouped with the x. It's going to be a vertical shift. Okay, so let's get started. The amplitude is going to be the absolute value of 3/2. So A is 3/2. So the amplitude, if you want, you can call it just 1.5. B is the number before the x. So the number before x is 4. So my period is going to be 2 pi divided by the absolute value of 4, which is pi over 2. So I actually am going to pause right there. I'm going to be moving this graph, so you're going to have to take that into consideration. But you'll see why I'm using a little bit of forethought to put my 0 here, and I'll show you in a minute, but just go ahead and do that. So remember, you count out 1, 2, 3, 4, and this is where your period goes. So since the period is pi over 2, I counted out 4. This would be pi over 4. Half of that would be an 1/8. 1 pi over 8, 2 pi over 8. Oh, that's 3 pi over 8. Now, mini graph, that's just reminding you that we're graphing cosine. So it starts up at its maximum and then x-intercept, minimum, x-intercept, back to the maximum. Reflections or shifts. So you have to do this. 4x plus pi equals 0. 4x equals negative pi. X equals negative pi over 4. So it's going to go left pi over 4. Left. Well, look at your graph. How many units on our scaling does pi over 4 represent? 1, 2. So everything is going to be moved over 2 units. So this is going to be negative pi over 8, and this is going to be negative pi over 4. So now what I'm going to do is label. So this is 2, that's negative 2. And I'm going to do my parent graph first. So that's before this stuff going on here. So it's going to go 1.5. So be careful when you do that. X-intercept, negative 1.5. X-intercept, 1.5. So there are my parent points. And then I have to move everything over left pi over 4, which represents 2 increments. So 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. So here is my graph. And it's going to keep repeating itself, but there's one rotation of it like that. Okay, so friendly reminder, this is what it looked like before it got horizontally shifted. Okay, now if I wanted to impose cosine x just because we've been doing it, I'm going to barely get a piece of it on here because the period was pi over 2. Remember with cosine x, pi over 2 is just the first mark after 0. So this is exactly what I would have. I would have just that first little chunk right there. It would obviously start going down, but this graph right here is super compressed. It's like smushed in. horizontally, and the reason why it's smushed in horizontally is because of that 4x. Alrighty, moving on to our last one for just sine and cosine before we move on to secant and cosecant. I have a sine graph. So A is -3, but the amplitude is always positive, so it's got a 3 from the midline. B is 2 pi, that's the number b for x. So my period is 2 pi divided by the absolute value of 2 pi, which is 1. My mini graph, it's sine, so it starts at it's got 3 x-intercepts and then 1 max and 1 min. And reflections, it's going to reflect about the x-axis, and it's going to go up 2 because of that 2 right there. It's not grouped in with the x. So because I'm not moving it left or right at all, I'm not going to switch my y-axis to be somewhere else like I did here. However, you probably want to make sure you're careful here, because even though I'm going to label this 3 and -3, once I graph my parent graph and then shift it or reflect it and move it up 2, it's going to go off the charts. So let's start by graphing. I'm going to start with pencil just so that we can see the first part. So without any transformations, only some stretching and shrinking. Oh my gosh, this is terrible. I forgot to label. Let's do this real quick. No radians because they canceled out. So here I am. This is 0. And then I'm going to go up to 3, down back to the x-intercept, -3, and then 1. And then now I have to reflect. If it's on the x-axis, it doesn't reflect. So here's that. And if you want, you're more than welcome to erase the 2 points that were before the reflection so you can see your 5 points right there. And then now I have to move everything up 2. And this guy is going to go up 1, 2. So it's going to be up at 5. And so what this graph will look like, wow, that really doesn't come in that way, does it? I'm being silly. Take that off of there. Do you see that it's midline right here? If this is the new midline for the graph, but it still has a distance of 3 and 3 from the amplitude. Alrighty, so that is how we are going to be graphing more extensive sine and cosine graphs, but it follows all of our other patterns aside from how we label, so it shouldn't be anything too terrible. Okay, so how do we graph cosecant and secant graphs? Well, there's only 2 additional things you have to do than when we were graphing sine and cosine. And it makes sense because when we're dividing by a reciprocal, anywhere the original function equaled 0, this one will be undefined. And the 2 ways we get undefined are with holes from canceling factors or asymptotes, and we won't have canceling factors. So cosecant and secant have asymptotes because of being undefined in certain locations. Okay, so when we say pretend y equals sine of x plus pi over 4, if we wanted to graph this, which is something we've been graphing already, we would go, okay, the amplitude is the number in front, it's a, and that's just the absolute value of 1. And then the period would be 2 pi divided by the number b for x, and there's not a number, so it's implied that it's 1. And then we would talk about any transformations. So stretching would happen because of our amplitude if it was happening vertically. And then our phase shift, we're going to set whatever's in with the x equal to 0. So we are going left pi over 4. So when we go ahead and set up our thing, we need to go left. So I don't really know how much pi over 4 is in increments yet, but I'm going to not put my line right at You might want to go over 2, but I'm not going to put it right at the beginning. So here's 0. My period is 1, 2, 3, 4, 2 pi, pi, pi over 2, and 3 pi over 2. So what you'll notice is pi over 4 is actually going to be like right here because it's halfway in between. So what we need to do is realize that we're only going to be moving it over half of one of our pre-drawn increments. So let's go ahead and we're going to dash out this. We're not going to actually graph it because we're trying to graph cosecant. But so the pattern for sine, I am going to scale this and make this 1 and this -1. We don't have to. You could just do it on the first line, but I'm just showing you options. And the pattern goes x-intercept, maximum, x-intercept, minimum, x-intercept. And then we need to move this over pi over 4, so everything gets moved over half an increment. Okay, so here is what that graph would look like. And I'm going to dash it out in my highlighter here. Okay, there's one rotation. It's kind of hard to see, but you guys, you'll get it. I'll dash it out in pen just to make it more visible. Okay, so there it is right there. So that is the sine graph. That is not the cosecant graph. Well, because cosecant is the reciprocal of sine, we're going to have some asymptotes everywhere we have an x-intercept, because if we get an x-intercept, the sine of x would be 0, so we're doing 1 divided by 0, which is undefined. So here is an asymptote. You literally just go to your x-intercepts and draw asymptotes. Don't make it more difficult. I explained to you why. You don't get it, memorize. Okay? And then the max points on the sine graph, like right here is a maximum, is going to be a minimum point on the cosecant graph. So that just means it's going to go like this, which is kind of cool, but also kind of annoying because it's going to stay within the asymptotic parameters that have been established. And then wherever there's a minimum, it's going to do the same thing. Okay, so on the test, the number one thing students forget is to actually draw the cosecant graph. They get the sine graph in there, but then they forget to go back in and do those 2 extra steps, asymptotes and max and mins, reverse. So that was a cosecant graph, and now we're going to go ahead and graph a secant graph. So we are going to pretend that this is going to be graphed between, we're graphing actually, all I'm doing is changing it to cosine. That's it. Okay? So then after that, you'll notice that it wants you to go from -pi to 5 pi, so we'll just have to repeat our pattern so we match that condition that they've asked us to do. So we're going to do our amplitude, which is the absolute value of -3. So the amplitude is 3. We're going to do our period. This is the one students have a hard time with. Remember, dividing by 2 is the same thing as multiplying by -1/2. So another way to write this is 1/2 x. So that means that the number before x is 1/2. And then I would have to copy dot flip that, so that's going to be 4 pi. Okay? And then any transformations, we have a reflection in the x-axis. And that's it, because this isn't going to be a phase shift. That's going to actually stretch out our graph. We would multiply all the x values by 2. We don't actually have to do that because it's taken care of with our period, so that's a little bit of a shortcut that we're teaching you. So the only thing is the reflection. So I'm going to go, this is 4 pi, so out 4 increments is going to be pi. So, and it wants me to go from -pi, so this is going to be 0, 1, 2, 3, 4 pi, 2 pi, pi, 3 pi, but it wants me to go from -pi to 5 pi, which we'll add in a second. We're going to actually still start from 0. I'm going to make this label my amplitudes, And then I'm going cosine graph, which is going to start up at its amplitude, intercept, well, it's a maximum, intercept, negative amplitude, x-intercept, positive amplitude. So if I were to continue the pattern, the next thing would be intercept. So that's getting me to 5 pi. And where did I come from? So you can see that you would have been an intercept right there as well. So there's the basic cosine graph, but then it's reflected. So I'm going to draw the reflected graph in this handy dandy pink highlighter. So this will stay the same, but this point will come down here. This point will be reflected up, down, and then up, and it'll look like, hopefully the pink highlighter is better than the, so those should be curves, not V's. They kind of look like V's, but when I'm going to draw my secant graph, it definitely won't. So there is my -3 cosine x over 2, and then I'm going to take all my x-intercepts and make them asymptotes. And I am going to take my minimums and make them maximums. And I'm pretty sure that's why this is here, this condition, because if we went from 0 to 4 pi, we would only be seeing half of part of the secant graph. It's still fine, but this way you get a better picture of what it looks like. You can graph these on your calculator to type them into your calculator. Because we're operating out of radians, you want to be in radian mode, and then you would type in, because there's not a secant button, you would do -3 over the cosine of x over 2, and it would give you the same graph as you would get for secant right there, because it's -3 times 1 over the cosine of whatever angle you have right there. So that's how you would get it. You can check all your answers in your graphs. Obviously, the scaling is going to be off because the standard scale on our graphing calculator is from -10 to 10. You can change that window. You can actually type in 0 to 4 pi and go by increments of pi. And maybe we'll have time in class to look at that, but for your own benefit for your test, if there's a calculator portion, it might be nice to know that so you can double check your graphs. And that's all, folks. Actually pretend to graph. We pretend it says y equals sine of x plus pi over 4. And then what we're going to do is we are going to take the x-intercepts and make them asymptotes. Why the heck would we do that? Because it's at those x-intercepts where the y value equals 0, and then when you flip your fraction for cosecant or secant, you're going to get division by 0, which is no, it's not okay, and so it produces an asymptote. And then anywhere there was a max point on the sine or cosine graph, it's going to be a minimum point on the cosecant or secant graph, and vice versa. So let me show you what this looks like. So my when I'm graphing these, it just doesn't actually ask me to do anything. So what we're going to do is we